So today we're going to look at gas meters. In the previous presentation we talked about the gas distribution side, and the last slide was talking about gas meters and then going to appliances. So we're going to look at gas meters. Gas meters have been out for a great number of years. Obviously it's one way that the gas suppliers can charge the customers, but there are different types of meter that you as gas engineers are going to come across in your career. Some of the meters we're going to look at you'll probably never see because they're old meters, but in the gas industry we never say never. I was talking to a gas engineer a few weeks ago and he came across an old gas meter that was nearly 80 years old. It should have been changed but it hadn't been. So without further ado, let's move on to gas meters. So what we're going to look at, the objectives. So what's the objective of this presentation? What do you need to get out of this to progress with your MLP progression? What is a gas meter? Whose responsibility is it for the gas meter? The different types of meter. Handling meters, so if you do have to handle a meter. Locations for gas meters. Protective equipotential bonding. The use of a volt stick. Temporary continuity bond, and how to fit a temporary continuity bond across a meter if you need to. So by the end of this module, which is gas meters, you should be able to show an understanding of what a gas meter is and who's responsible for that meter, the types of meter you could come across and how to handle them if you need to, gas meter locations, where you're going to find a gas meter, protective equipotential bonding, what it is and the responsibilities of a gas engineer, and how to safely remove a gas meter if required and when we would need to remove a gas meter. So that's just a cartoon of me back in the day changing a gas meter. So what is a gas meter? It's a specialised flow meter. It's measuring the volume of fuel gas used, such as natural gas and LPG, liquid petroleum gas. So we've got to charge customers for gas, so we need to know how much gas they're using. It tends to be used in residential, commercial, industrial buildings that consume fuel gas supplied by a gas utility. So in the previous slide we looked at the gas utilities. We saw we've got Northern Gas Network, Cadent, Scotia Gas and the other ones that were involved in there. So if we're measuring gas, it's more difficult than liquids. We've probably all poured a cup of tea, we can measure a liquid, but gas, it's affected by pressures and temperatures that can affect the volume of gas we use. So it has to be more specialised how we measure it. A gas meter measures defined volume regardless of the pressure and quantity or the quality of the gas that's flowing through the meter. As we said in the previous presentation, we import gas from all over the world, and some of that gas hasn't quite got the same calorific value as other gas, so you don't get as big a bang for your buck. So there are several different designs of gas meter in common use. Again, it depends on the volumetric flow rate of the gas to be measured and the range of flow rates anticipated. So in your domestic house, you'll have a smaller gas meter than in a factory that uses gas as part of the production. They've obviously got to use a lot more gas, so they'll have a meter capable of using and measuring that volume of gas that they're using. So it's the gas supplier's responsibility for the meter and making sure it works correctly. So you as a gas engineer, if you go out and you've got a suspicion that there's a problem with the gas meter, you'd need to get in contact with the gas supplier. The key responsibility for meter position lies with what's called the Meter Assessment Manager, or MAM. It's the company with whom a gas supplier or gas transporter contracts to provide the metering service to the customer. So as we all know, I buy my gas from British Gas. British Gas will contract somebody like Cadent or Northern Gas Network, dependent on where you're located, to be responsible for that gas meter. So that's who I would contact if I'd got a suspicion with my gas meter. So it doesn't matter who is supplying the gas, Octopus, British Gas, any of these companies that supply gas, It's normally, they contract it to companies like Cadent, Northern Gas Network. They're responsible for the gas meter. So we have a national gas emergency service provider, and that's who a customer contacts if they smell gas or suspect there's a problem. That's who you guys contact if you need to report an issue. So if you're in course of your doing your job, if you've got any concerns about the gas meter, gas escapes outside, that's who you would contact. So it's a good idea to have this number in your phone, 0800 111 999, and put it under gas emergency provider. That way you've got the number, and it's also important that that number is on the gas meter so the customer's got contact details, who to get in touch with if they should smell gas or they think they've got a problem. So gas meter boxes. Meters can be fitted outside, can be fitted inside. So outside the meter box is actually the responsibility of the customer, the person that owns the property. So if that meter box becomes damaged through vandalism, or a lot of them are parked down drives and they get caught by a car, it's down to the customer to contact the supplier. Now they may come out and replace that meter box free of charge, they may charge the customer. So if the meter box is damaged, again, it's the emergency service provider, and they will decide, and the bill would go to the customer if necessary. So they're the ones responsible for the meter box if it's in an external meter box. So gas meters come in various forms. They brought about the method used to measure the volume of gas. The amount of gas the meter is capable of passing, as I said earlier, in a factory they're going to use more gas than in a domestic property, so they'll need a larger meter. So that's a standard meter. It's what's called a G4. That's the term that's given to that particular meter, and that's got a digital display. So if we look at the display now, what you can see there highlighted in red, that is the test index. Before that, you've got the billing index. So the 5 numbers before that, where the comma is, that's what's used to bill the customer. The ones highlighted in red, they're the ones that we use when we're measuring things like gas rates. We're going to be looking at that in a later presentation, understanding gas rates and how to measure gas rates. That meter is what's called a U6 meter. Again, it's a metric gas meter. There's just 2 types of meter. They're the ones that are in common domestic use. And again, you've got that similar display where you've got the 5 numbers for the billing index and the 3 highlighted in red. They're the test index. That's an older U6, but it's an imperial meter. So the old feet and inches, that's most of you guys probably won't be familiar with, but somebody like me, I learnt that in metric at school. I'm of an age that learnt things like that. So that one is a slightly different. Again, we've got a billing index, which are the 4 white numbers, but for testing these and checking the gas rate, we use that test dial, the one there that has the number 1 at the top and the 0.5 at the bottom, and the red hand that's going to move round. That's now a modern meter, an E6, an electronic 6. And I'll come on to why they're called 6 shortly. So that's an electronic meter. A lot of meters now we're going on to smart meters. These that you can have a smart meter monitor. So you can have an electric meter, a smart meter, and a gas meter on a smart meter. They, through your Wi-Fi system, can communicate back to the gas supplier, and they can make sure that your bill is up to date and you're being charged the correct amount for the fuel that you're burning. As we can see on that one as well, we've got the yellow label there with that phone number that I mentioned. It's important when you go out and you're dealing with gas meters that that phone number, the customer understands it. Make sure they've got that phone number, and that way they can get in touch if they suspect there's any problems. That's what's called a subterranean meter. They're fitted in a meter box outside. There's a little flap comes down. That meter there is hidden underground. It's not always as easy to spot those. And that's one that's been attacked by spiders. And in your careers, you'll probably go out something like that. And if you're a bit of an arachnophobia, if you suffer arachnophobia, you might want to put your gloves on or get a duster or a brush in there to get rid of the spiders before you start working on it. They're old gas meters, they're coin meters. Years and years ago, people that got into debt recovery was they had meters where you could put a 50 pence piece or a pound coin in. They're no longer used because of the volume of gas people use. It wouldn't take too long to fill those up at the gas prices they are, and also there's the opportunity for theft. The meter could be stolen, then the customer would lose the money that they've put in there. But again, you could still come across those in rented properties. Some landlords have what's called a secondary meter, and they will use a coin meter to charge the customer. So you may come across something like that in rented accommodation. That's why it's on there. The one on the right is what's called a quantum meter, and basically that had a card that went into it. That's a very early type of, when they went away from coin meters, they went onto these credit meters where people went to the post office and got their gas card topped up, and then they could put that into the meter and it would charge them their bill and it would pay off any debt. That's a modern one on the left hand side now, that white one, and again it's got a slot in there. It just looks like an E6 meter, but it's got a slot so the customer gets a card. They can now do that over the internet. They don't, or the corner shop, any of these places which can top their gas card up so they can maintain the gas. They charged a little bit more than somebody with a credit meter because it's to pay the debt off. So again, you can come across those type of meters. That's a larger U16 meter. That's the largest meter that as a domestic gas engineer that you guys can work on. There are larger meters, but you would need to be commercially qualified to work on those. So things like U16 and the next one, which is G10, that's just a different version of a commercial type meter. They're the ones that you can work on. Anything above that, you would need to be commercially qualified. Out there in the domestic realm, you'll be unlucky if you come across a domestic property with anything larger than a G10 or a U16. It's usually your standard size gas meters that you're going to come across. So these are the smart meters that we're all moving on to now, and there are several different types of smart meter out there on the market from different manufacturers. Companies like Landis & Gyr, Liberty, Elster, we've got Floridan, and we've got Itron, and they all work slightly differently. All the screens on these go to sleep when they're not being used to save the batteries. They've got a limited battery life, and what you need to do if you're working on them or the customer wants to check the reading is wake them up, and there are different ways, different methods of waking them up. Now, if you're going to remove a gas meter, why would you want to remove a gas meter? Right, so you may be doing some solder work, and again we're going to be looking at pipe work and things like that later on through the process of going through the MLP. So if you're doing any solder work close to the meter and that meter's full of gas and you're using a blow lamp, we know that gas is explosive, gas is inflammable, and we've got a naked flame. We generally remove the gas meter and cap that meter off. So that's why we need to handle meters. So we need to cap the inlet and the outlet after we've removed it. Not only does it stop the gas coming out because gas is lighter than air, it stops dirt going in and it stops damaging the meter. It also stops things from dropping in there. When we take it out, we make sure we don't scratch the meter or damage the case, because that can cause it to rust and therefore it can cause damage to it. We need to keep them upright, particularly the smart meters. The smart meters have got anti-tilt devices in. The suppliers are concerned that if somebody's removing a meter, why are they doing it? They might be doing it for theft purposes, stealing the meter, trying to fudge the meter, trying to bypass the meter, trying to get free gas. So therefore, that's why we've got to make sure that if we're handling a meter, we keep it upright and we treat it gently. It is a piece of equipment that measures things, so we've got to treat them gently. The other thing is, if we don't do that, some of the older meters, they've got valves in there, and we can get dirt in the valves and we can cause them to stick and to lock up when we put them back. So when we're taking meters out, if we have to, we've got to treat them with care and treat them gently. If we shake them about, the anti-tamper device is going to kick in, and you're going to be stuck with a meter that won't pass gas. Yep, there is a cure. You've got to ring the gas supplier and apologise, and they'll come out and they'll probably replace the meter. They won't be happy and they may charge, because we should, as qualified gas engineers, understand how to handle and remove meters. That's something we'll do in a practical sense when you come into the centre. So when we're putting the gas meters back in, we don't over tighten the connection. We're working on gas, not working on steam. We don't need to really rive them up. If we over tighten, we can split the rubber washers that are on there, and that could cause a gas leak. Years ago, gas meters used to be fitted into cellars. They don't tend to be fitted in cellars these days because cellars are damp, and modern houses don't tend to have cellars. And the problem is, damp surfaces used to cause the meters to rust and cause corrosion and cause problems. Make sure when we're connecting a meter up, there's no dirt in the pipework or anything like that, which is going to cause problems. So, if we're putting a meter box in an external installation, the meter box must be designed and constructed to ensure the event of a gas escape inside that box. The box is designed so the escape can't get into the property. We don't want gas in the house because therefore we could have an explosion. We don't want it in the cavity. We have to sleeve the pipe as it goes through the cavity. It's got to be an approved meter box. It's got to be accessible at all times. Not only for the customer to get access to it if they suspect they're smelling gas, they've got to turn the ECV off, but for us when we're working there. During our normal work, when we're installing, we're going to have to do gas rates, tightness testing. We're going to have to access the gas meter. Even if we're going out to service an appliance, we're going to have to do gas rates. We're going to have to do tightness testing. So we need access to that gas meter. So if we turn up and the customer's got things in front of the gas meter box, we've got to explain to them we need access, they need access in case of emergencies. So we've got built-in meter boxes. These are ones that are built into the wall. Generally a new build house will have a meter box built in. So all you'll actually see is probably 50mm sticking out with a door on it, and the rest of the box is inside the cavity. They're fitted on the outside wall, and the gas main comes up on the outside. They've not got to be more than 2 meters from the front wall. The base of the box should be located between 500mm and 1000mm above the finished damp-proof course. Too low and we could get damp going across. The ECV, the emergency meter control, is located at the front left-hand corner, and the handle should be securely fixed in position. So that's a diagram explaining it. So we can see the polythene pipe coming up there, and then the pipe work is coming. In this instance, it's coming off the top of the meter through the box and entering the property underneath the box. However, if it's normal pressure, low pressure main, that pipe could go straight through the back of the box. It would have to be sleeved and it would have to be sealed, but that's something that you could come across. We can get surface mounted boxes. If there was a gas emergency and the meter was installed inside the property previously, the gas supplier may deem that it's more appropriate to put it externally. So that meter box wouldn't be fitted into the wall, it would be drilled onto the wall, so that would stand out probably 250, 300mm from the wall face. And they're designed to be stuck on the mounted on the outside wall. There's no building work required for these, so that's why the gas supplier will put these on there. They don't need to cut into the fabric of the building to put an internal box. And again, the ECV is inside that box, and it's usually on the bottom left-hand corner. There's different types of surface mounted box. So they've all got a door on the front. Some of them you can remove the full front cover by removing a couple of screws or a couple of clips. There are different types, which you may need to totally remove the cover off them. When you're just doing a tightness test, all you need to do is open the door, and it's a triangular key that you would use, and all the meter boxes use all the same key. So a meter box key, that's something else that it's worth getting hold of because you're going to need one to access meter boxes. So again, that's showing an external meter box, and that's just explaining how to remove it. So it's undoing the screws. lifting it off if you need to get access to the pipework and do anything on that. But a tightness test, a gas rate, you just open the door and work on it that way. So we mentioned earlier the semi-concealed box, the one which gets the spiders in and occasionally gets damping. They're generally fit or installed from scratch on new build properties where they don't want the box to be seen. So these can be on the front of a property, hidden generally with bushes and things like that. These have special meters in them. It's not your standard gas meter. It has a slightly different regulator on these that you've got on a standard gas meter because of the connections on it. But from our point of view as gas engineers, we can do exactly the same on a semi-concealed meter box as we can a wall-mounted meter box. Tightness testing, gas rating, all the things that we need to do. So that again is just showing a picture there, and it's explaining about the size of it. The bottom part is going to be below ground. You've got the ground level which comes across, then the outlet pipe is coming through. The pipe should always go through into the property above the damp proof course, not below, because if it goes below the damp proof course, we're going to get damp going into the property and then the customer's going to be causing problems. So again, if you're doing a first fix and there's a subterranean gas meter there, so first fix is you're the first person putting pipe work in, you'd always go above the damp proof course. Now, gas meters can be fitted in properties, and they were for years and years and years. When I first started in the industry, most gas meters I went to, they were in the cellar, they were under the stairs, they were inside the property, and we can still come across them because there are still meters there. They're all over the place, and again, the ECV has always got to be accessible, so if it's under the stairs and somebody's thrown lots and lots of things in, we've got to explain to the customer we need access to that ECV, because if there's an emergency, they need to turn it off as quickly as possible. So, a house entry tee will be installed only on installations less than about 20 years old. Older installations may have a direct connection. So, a tee is basically where it comes in through to the property. The gas pipe's coming up, it's coming through into the property with the ECV, and at the top of that, there's usually a little grub screw and a cap. The cap comes off and the grub screw can be screwed down by the emergency service provider to shut the gas going off to that property. So if there was a major incident and there's nobody at home, they can isolate the gas to that property by doing that. But that's only on properties that are less than 20 years old. Older ones, they'll just have a metal pipe. It'll still have a cap on it, but there'll be no grub screw in there. It's nothing for us to worry about as gas engineers. That's more about the gas suppliers. So that's a gas meter fitted in a garage, and as we can see, we've got the ECV. Another thing that is worth mentioning is the on-off tape. The on-off tape's there to indicate to the customer which way that the handle on the ECV needs to fall. It should always point upwards to on and then fall at 90 degrees to go off. It should never be the other way, fall into the off position. Fall into the on position, because therefore if we shut it off, it shouldn't be that. The other thing that you can see there on the just above where the engineer there is removing the test point, we've got a green and yellow lead. That's earth bonding. Now the electricity regs say that our gas pipe should be electrically bonded, and it's got to be within 600 millimeters of the pipe coming off the meter, and it's got to be before the first tee. If it hasn't got that on there, we've got to make the customers aware of that. We'll talk about that later on, but that's something that we've got to be aware of, this equipotential cross bonding. What that's for is to make sure if an electrical fault occurs, the meter is earth, so the meter doesn't become live. And in that case, we might touch it and we might get an electric shock off that. So it's making sure that we're safe to work on that meter if we need to. So this protective equipotential bonding, or PEB, where the gas service pipework up to the meters is considered an extraneous conductive part. So basically anything that could touch electrics, its requirement is to protect it from equipotential bonding. So that PEB, protective equipotential bonding, to any continuous conductive installation pipework, so gas pipes have got to be made out of copper. Copper's a very good conductor of electricity. So we've got to make sure that that has got earth bonding on it. And that earth bonding should go back down to the main earth terminal in the property. Again, that's generally an electrician's job, but we've got to make sure as gas engineers that that meter has got that equipotential bonding on it. The bonding's used there to reduce the risk of an electric shock for anyone who may touch the two separate parts where there's a fault. So for argument's sake, right, your body is very good at conducting electricity. We're stood on the ground, so we're stood on earth, and electricity always wants to go to earth if it fails. If we touch that meter and that meter is live, the electricity will pass through us. Now it could cause electric shock. It could in some circumstances, and has in the past, cause us to be electrocuted, which is fatal, and we don't want that. So that's why it's important to make sure there's equipotential bonding on there, and if there isn't, we make the customer aware of it. So that's a diagram which explains about equipotential bonding. So we've got the meter on there. Also the water pipe, the copper water pipe would have a bonding on it, and any other pipes, so things like pipes to radiators, metal pipes to sinks and anything like that where there's a potential for electricity to go onto that copper pipe or onto that radiator, onto that meter, they've got to be cross-bonded. So it all goes back to a British standard, BS 7671, and that came out in 2018. Requirements of electrical installation. Now we're gas engineers, so we work to the gas regulations. Electricians work to the IET wiring regulations. And in clause 554 1.1.2 it refers to metal installation pipework supplied by metal service pipes. Now modern service pipes tend to be plastic. We still put equipotential bonding on there, even though that service pipe is made out of PE, which is plastic. Polyethylene plastic. We still have potential there because the gas pipework is made out of copper, the meter's copper. And it says where practical requires the protective equipotential bonding protects the installation within 600 millimetres of the meter outlet union or at point of entry to the building if the meter is external. So it could be in the meter box, it could be inside, and the connection should be made before any branch, so any T, it's got to have that before no more than 600 millimetres from the meter and before the first T. They're the important 2 points to remember about equipotential bonding. So that's just showing one in a meter box, and that's showing the two positions you could have the bonding. One is external in the box and the other one is internal just as the pipe comes through the wall. So if that box was on a garage and there was nothing inside the garage, the pipe's going to come through and you might see the bonding on there. If we can't see the bonding, we assume it hasn't got it and we make the customer aware of that. Where it's us, the Gas Safety Installation and Use Regulations, Regulation 18.2, it places a duty on us as gas engineers to notify the responsible person that equipotential bonding may need to be connected to the installation in the premises. And then we've got IGEM, Institute of Gas Engineers and Managers, G11 edition 2 communication 1840 gas industry unsafe situations procedure. These are the things that we have to work to as gas engineers. Protective equipotential bonding. So this is the unsafe situations procedure that we've got to work to, and in that it talks about 3.19 equipotential bonding not installed or inadequate, not secure. So it might have a clip on there and it's not tight. It's not been secured properly. It might not have the bonding. Our responsibility as a gas engineer is to leave a bonding notice with the customer. That's what we've got to do to comply with the gas industry regulations. If we don't do that, we're not complying with the gas industry regulations. So we could be brought to task about that, and it's all making sure that we're doing our job properly. And that's an example of a safety notice, and you can buy these and you can hand it out to a customer and just explain to them, I've noticed that your electrical bonding isn't sufficient, it isn't there, and explain to them they need to get an electrician in there to sort that out. That's us covered. We've covered ourselves by handing that notice to the customer. So, volt sticks. The reason we'd use a volt stick, and the reason we're using a 50 volt stick is death has been recorded as low as 60 volts. So if we touch something and there's over 60 volts in, we could be killed. So that's why if we're using a volt stick, companies like Northern Gas Network, Cadent, all their engineers will have these volt sticks, and before they touch the meter or the ECV, they'll put that volt stick on there, they'll test it before they use it, they'll put it onto a known electrical supply, so near a socket, and then it will glow to say that it's illuminated. They'll then put that onto the meter union, onto the pipework, and if it glows, as in the picture there on the side, that's indicating that there's some electricity in that meter, so you wouldn't touch that. You'd explain to the customer they need to get an electrician in and show them what's happening, because if we touch that, there's a potential for us to get an electric shock, and it's important that we don't get an electric shock. We want to go home at the end of the day. If we're removing the meter, what we need to do is put a temporary continuity bond across it. That way, because if we remove that meter, we're breaking that circuit from the inlet to the outlet. The meter is across that inlet to outlet, so we're putting a continuity bond on to maintain that circuit. Because if we remove that, we could get a spark. Even though we've tested it, we want to make sure we do the job properly. There's different types of continuity bond, as you can see from the picture. So, determine where we're going to start to put the bond. It should be made, if there's paint on the pipework, we've got to scrape that paint off, because we're not going to get a good contact. Paint is a good insulator, so we're not going to get a good electrical contact. We need to have a nice piece of bare metal that we're going on to. So the first thing we're going to do is connect the temporary continuity bond, what's called upstream, so back down towards the gas meter, round about where the ECV, the emergency control valve, is. That's the first connection, and then we'll connect downstream, which is the customer's pipework. So we're going to connect it on in an appropriate place. So we're putting that on, and as I've just said, we're going to go upstream first, then downstream. So once we've got the bond on, we can remove the meter without fear of any sparks. Obviously, we're going to cap the meter, as we said earlier on. We're going to put it in a nice safe position so it doesn't get damaged, doesn't get any dirt in it because it's got the caps in. We're going to carry out the work that we need to do. Then when we're putting it back on, we connect the meter back up, and we'd always remove the downstream clamp first. It's just what we do, and then we're going to remove the upstream clamp. In any case where it's necessary to prevent danger, no person should carry out work in relation to a gas fitting without using a suitable bond. This is from the gas industry, unsafe situations. This is the gas regulations telling us this. It's not me making rules up. This is what we've got to work to. It's what I've worked to all my years in the industry. So this is how we do it. It's all about making sure we do things properly. So if we're removing that meter, we've got to leave that bond in situ. Now that could be if the job's taking 2 or 3 days, it's an empty property, we might have that meter removed 2 or 3 days. That bond would have to stop on there until we're ready to put the meter back, and then we can put that bond, we can remove the bond once that electrical circuit's been restored. So that was all about gas meters. So you should have a better understanding now of gas meters, what a gas meter is, identifying the different types of gas meter, the size of gas meters, and all that type of thing. So until the next time, when we're covering another subject, thanks very much for watching, and I'll see you in the next presentation.